welcome you to this material science class. This is the third class, and today we are going to concentrate over diffusion. Diffusion is nothing but the movement of molecules from one medium to another medium through a particular arrangement of molecules. Whenever a balloon is filled with air, air may escape out through the rubber wall of the balloon. So pressure decreases. So this is a type of diffusion. So air molecules, they move through the wall, the molecules of the rubber or balloon, whatever may be. So whenever gas is filled in the cylinder, it may escape out through the molecules of the molecules arranged in the wall of the cylinder, but not much, but slowly, very slowly. Therefore, when you keep it for a long time, the pressure is slightly it's reducing. That's due to diffusion. And whenever the diffusion takes place, you can see in the figure, there are large molecules are more concentrated at their particular place. Now they are moving. When they are moving, their concentration changes. The dense of the molecule gathering is changed. And also, whenever the diffusion takes place, the rate of flow of molecules that's proportional to rate of change of concentration with respect to thickness of wall. So it's given by rate of change of molecules per unit area. That's called as flux density. It may be denoted by J, and that's proportional to rate of change of concentration of the molecules. So the scientific analyst, and he has given the first law of diffusion. J is equal to chi, in Greek letter chi, and dc by dou c by dou x. J is flux density, and it indicates by minus, negative. Minus tends to indicate reduction. It's reducing. And whenever this one is, if it is increased, it may be given as positive. So that gives the rate of change of concentration. G, flux density, it's always expressed per unit area. The fixed law, it's indicated by J is equal to minus D. Minus D is nothing but diffusion constant, and it's also negative, and this also depends upon the rate of change of movement of flux density. With respect to time, it varies. Dou c by dou t is equal to chi dou square c by dou t dou x square. Dou f by dou t is also equal to C into d by dou square f by dou x square. If we substitute the value of dou f dou c by dou x in that place, you can get this expression. So diffusion, that depends upon time, that depends upon thickness of wall. So this diffusion results in decrease of concentration and decrease of corresponding decrease of pressure. These are the important things in diffusion. And the next important thing is plastic deformation. We are going to concentrate over plastic deformation. Whenever external force is applied on the body tends to change its shape or size. When the force is removed, the body may come back to its original position. It can be viewed in the materials like rubber. When it's stretched, its length is increased, and when you remove the force, it comes back to the original position. The property is called elasticity. The deformation is called elastic deformation. But when the force is applied after the deformation, it does not come back to its original position even the force is removed. Then it attains a newly deformed position, which is called as plastic deformation. So there are two types of deformations. One is elastic deformation, another one is plastic deformation. So in this subject, we are going to concentrate over plastic deformation, because in the engineering field, several materials are used and they are deformed into different shapes by various processes. Therefore, we should understand the fundamentals about the plastic deformation. In the plastic deformation, there are two main mechanisms. One is slipping, another one is twinning. Slipping, the atomic plane moves over the other plane, and hence the body gets fractured. One part of the body moves over the other body over a particular plane, that's called as slip plane. The plane where the shear stress is more. There that slip takes place. So slip takes place in the direction of critical shear stress components. So the direct stress can be resolved in two components: shear component, normal component. Slip takes place along the direction of shear component. This is called slip plane. The direction is called the slip direction. The whole system is called a slip system. Whenever it attains the maximum limit, then slip takes place. Slip may take place more than one plane. Maybe in two different places or three different planes, and so on. Also, in the case of twinning, whenever the external force is applied, the mirror image is formed. One part of the atomic structure becomes mirror image of the other part. That's formed permanently. So that process is called as twinning. And the part in which the atoms are displaced, that's called as twinned part. Twinned plane, twinned part, or twin plane. Due to this twinning, the properties may be slightly varied depending upon the area over which twinning takes place. So whenever a metallic part its force is suddenly applied, or when it is suddenly cooled, whenever it is heated to high temperature, and if it is cooled to a low temperature at a slower rate, then the process is called as annealing process. So during this annealing, the twinning may occur. So mechanical twin and thermal twin, there are two types of twins. Mechanical twin, that's due to external suddenly applied load. Thermal twin, that occurs due to heating and cooling. Heating to high temperature and cooling at slow rate. So these things may affect the performance of the body whenever it's used. Therefore, whenever the engineers select the material, when the materials are used for a particular purpose, then they should analyze the opportunities where the twinning and slip to occur. The material which has more critical resolved shear stress should be selected for a particular purpose. The material which can withstand the impact load or annealing should be selected for a particular purpose. So the purpose, according to the purpose, you have to design the particular product and you have to select the suitable materials. So for that purpose, these things may help. So the examination point of view, there may be some question in the diffusion, or there may be question from slip and twinning. Slip and twinning are most important. Comparison may be asked. Slip and twin, maybe you are asked, may be asked to compare. Comparison. Slipping, mirror image is there. In slip, mirror image is not there. In slip, one part of body moves over the other body and therefore crack may occur. But a twin, it takes place internally, so the crack may not occur. Slip occurs due to shear component. Twin occurs due to suddenly applied load or impact load. It may also occur due to annealing, heating and cooling at slow rates. So in these ways it can be compared. Comparison may be asked. So just concentrate over the notes and try to understand it. If you got any doubt, feel free to contact me. Till then, we shall switch off. Thank you.